Did anyone check for mistakes in my calculations for exercise 11 and that arithmetic part? I know it's summer, so it's a little bit too much to ask, but it'd be a good idea that you actually do look at these recordings, because it'd be a good idea to start, because this is probably totally new that we encountered at this stage. And I pulled out that previous lecture that I was asking you to check for mistakes, so I can actually show you where mistakes are. Remember, it could be incorrect answer for the first way of doing the problem, and there was so it was a first way of doing the problem, there was a second way of doing the problem, and the issue was both answers were supposed to be the same, but they were not. And turns out they both were wrong. I just looked at it before class and I noticed that 3 times 8 is 24. So if you have a 28 minus 24 is 4 plus 6, which is 10. And same here, I think, double check this. We have 22 minus 26 and plus 14. So is that going to be also 10? Looks like 36, right? If you put these two together, it's 36 minus 26. Yes, it is. And that equals to 10. So it's not hard, but you really want to get a paper, pen, and do it, because that way you gain confidence. Because if I ask you something like that for the midterm exam, well, you should feel good about this, because it's really nothing in here, but it's still a good idea to work out these little problems before the exam time. So anyways, try to look at this. Again, I send this recordings. It's not really much, like 37 minutes or so. I emailed it to you last Wednesday. So try to double check this, because the answer has to be the same, because the answer is always the same. So anyways, I guess I'm not gonna get into this any deeper by now, because I think you should probably over weekend put a little bit of time in this. Now, system solving, we already learned how to solve systems, and there is another method of doing it that is good for using computers. I'm not going to worry about it. I'll just skip that stuff and move to the section 4 of chapter 11 that deals with various matrices. So the difference in determinant and matrix, you have this little bars, you see those bars. And in determinant, there's just, actually, there's a bracket, right? There's brackets in the matrices, and determinant has bars. That's important to realize what you are looking at. Is that just a matrix, or that's just a determinant? Because determinant is a number. You get some kind of operations and produce the number. And that's what determinant stands for. But matrix is just a bunch of numbers. And there are various examples of these matrices that section 4 of chapter 11 provides us with. So section 11.4, that has the matrix of various sizes. So here they say it's size 2 by 2. So the way that we treat those sizes, that we have 2 rows. So there are 4 entries here, 5, 0, and negative 6, 1. So that matrix has 2 rows. There's row number 1 and row number 2, and 2 columns. So you can now treat it not horizontally, but vertically, and you see there are 2 columns, first column and the second column. So we should be able to somehow keep track of those sizes of the matrices. So in the part B, looks like we have only one row. And like I say, Alex, careful, it's not one row or one row. Well, looks like that's the only one row, right? But columns will be first, second, and a third. So it'd be 3 columns. So they say it's 1 by 3. So matrices have various sizes, and they don't have to be only square matrices like 2 by 2, or like in the part C example, 3 by 3, 3 rows and 3 columns. It's 1 row, second, third, and so forth. So they could have pretty much any size, but there should be same as many entries in each of these rows or in each of these columns. So that's the first observation that people make. And now they start to work with matrices of the same size in order to add, subtract, multiply. Well, they don't divide. They just add, subtract, and multiply. Like, for example, in the next part, in example 3, there are 2 matrices of the same size. And what will be their size? Well, looks like both matrices NA and B here have 2 rows, right? Same here, 2 rows. And columns, looks like there are 4 of them, right? Because in each row we have 4 entries. So there are 4 columns you can think about. And they have same sizes. They are both 2 by 4 matrices. And that makes me to add them to be able to subtract them. And turns out to add and to subtract is not hard because you just add and subtract corresponding entries, which means that if you add those matrices, then I take the entries that in the upper left corner, the first entry of first row and the first column, which is 2 and same here, corresponding to it. And 2 minus 3 will give us -1. So they actually carefully show this procedure when you add these matrices or when you subtract them. So 2 and -3 here, when you decide to subtract, you get minus and minus is plus, right? So it's +3 and 2, which is 5. And again, there's nothing in it, it's just odd numbers that just random numbers, basically. They add and then they subtract, so you could just follow through these arithmetic steps if you feel like it. So we will do this when we go to the exercises. And one more thing they do is they multiply matrix by the number, by the constant. Let me show that in the next example here. So here's the other thing. So not just adding the matrices. Maybe I'll stop sharing and then share this again. So this way we get better and faster clean this page. So you can multiply matrix by any number. So what does that mean? So if you multiply by 4, then every entry of this matrix has to be quadrupled, multiplied by 4 each entry of the matrix. So whatever it be, so you can right away multiply 3 by 4 is 12, 1 by 4 is 4, 5 by 4 is 20. It takes a lot to write, but when you just multiply by 4, I'm sure you know how to do this. It's -8, 0 times 4 is still 0, and then 24, and that's what you get as a result. I think they've done a very good job by showing us the processes here, how they multiply matrix by number and then add or subtract them. Like in the part C, they multiplied first matrix by 3 and the second by -2. And once they did all that, they put them together. So they ended up with this result. So I'm sure instead of reading all that, you could just do this much faster, right? You could just go ahead and say, my first matrix, a triple, 3 times 3 is 9 times 3, 1 is 3 times 5 will be 15. And then same with the second row, minus 6, right? 3 times -2. 0 is my favorite. Times by 0 is always 0. And then 6 times 3 is 18. And notice we're already in this stage. And same you do with the second matrix. So you take this second matrix and you multiply by -2 all the entries. And that's what they actually did. They actually multiplied by 2 and then they subtracted. Or you could multiply by -2. That's what I would do, because adding is always much more fun. So if I multiplied by -2, I would put -8 minus 2 and 0. Because the answer, remember, is always the same. Or if you do it twice, you might get both answers wrong, like I did last time, but I guess we fixed it in the beginning of today's class. And I highly recommend you to actually do this yourself. And this way you will get definitely more confidence in yourself dealing with this arithmetic. So -2 minus 3 is +6. So now we're going to end up again with the same size matrix, because we're going to have 3 entries in each of these 2 rows. So 9 minus 8, corresponding numbers are 1. 3 minus 2 is 1. 15 minus, actually plus 0 is 0. -6 and -12 is -22, right? 0 minus 2 is just -2. And then 18 and 6 is 24. So we produced the answer that they have here for us. So I'm sure if you do this once, then you will say, no, it's not hard. I just want to not to hurry. So there's various other things that people deal with when they encounter matrices. And the matrix multiplication is probably the most unusual. So I need to block this number. So I usually do the following. I just block. That's why nobody bothers me. When somebody calls me, I just block them. Otherwise, they're going to call it all day long. So anyways, I will take a look at example 6 that has extremely unusual procedure. It's called multiplying matrices. And that's something that will really surprise you a lot, because it turns out that when you multiply one matrix by the other, you're going to end up with just a matrix of size 1. And I think they should have actually stressed it here, that it's not the number, whatever they produced, it's just the matrix that has size 1. Because here you're multiplying matrix 1 row that has 3 columns in it, right? First, second, and a third column. And you multiply it with the matrix that has 3 rows. Look at that. And only 1 column. So it turns out that as a result of this multiplication, what you're going to end up with matrix of the size 1 row and 1 column. So it's just 1 element here, minus 21. The reason is that these two are the same. You can multiply. And it turns out you could multiply them vice versa. So if you multiply 3 by 1 size of the matrix by matrix size 1 by 3, in other words, if I commute these 2 matrices, so these are the same, so they disappear. As a result, I'm going to end up with matrix size 3 by 3. That's going to be a big matrix. So Alex, what are you talking about? Are you sure? Yeah. Let's see how this, probably the most unusual process that you encounter in math classes, actually works. 3 rows, and also there'll be 3 columns. Don't want to make too much mess, but I can do. It'd be a big matrix compared to the previous result. So how does multiplication work? You multiply an always row from the first by the column from the second, and then add the results. So notice they add the results of this multiplications. So what they multiply is 3 with 3, 5 with 4, and corresponding 2 with -5. That's what they wrote. 3 times 3, minus 5 times 4, and 2 with -5. And then they add all that, and they end up with -20. Let's see, so how are you going to multiply, as you just said, vice versa? Well, let me write them. 3, 4, -5, that's my first. 3 rows and 1 only column. And you times this, so you put this crosses times, or they don't put any sense. And that's going to be 1 by 3. So it's going to be only 1 row, should not put just 1 row, but 3 columns. So this is going to matrix. I put brackets. So it has 3 minus 5 and 2. And then when I start multiplying, I go row, which is here, row, times the column, just like in the previous. And I put this in the position of first row and first column, which is right here. Enter in the row number 1, column number 1. And it has 3 times 3 in it, because there's nothing else, nothing to add. So next, I'm going to multiply, I'll keep going, first row, now by the second column. So the entry is still going to be in the first row. Sometimes people say row number 1. So first row. And the second column will have a value 3 times -5. And this will be -15. So we'll get this in the next stage. My goal is just to show you how this unusual process works. And finally, I still multiply in my first row. So this is going to be in the first row by the third column. And that will be a product of 3 times 2. See how I'm producing this first row? Now I'm going to get the second row analogously. So I'm going to take no longer this number 3, but the second row, whatever it has, it happens to have number 4. And I multiply it by 3, and that'd be now second row, and that's the first column, so it'll be a product of 4 by whatever is in that column by 3. And then I go again, but for the second entry, like in the middle of this matrix, I get 4 times -5. And finally, that number 4, I'm going to multiply it by the last column. So it'll be the result in this last column, so it'll be 4 times 2. How about that? And finally, I can move on to the last entry in here. And my last row in the third row. So R3 entries. And again, I'm producing them by multiplying first -5 by 3. And etc. -5, I multiply by -5. Everything there. And finally, -5, I multiply by next entry, which is 7, 2. 7, 2. Just like that. And I get the result, whatever these products are. So it'll be 9 minus 15 and 6. And also 12 minus 20 and 8. And finally, minus 15 and minus 25 and minus 10. See, this is just amazing. You just multiplied then vice versa. So that's a product of, they call it as R and C. But so that's a C and that's R. So multiply these two matrices. And they actually given me matrix of the size 3 by 3, 3 row and 3 column. But if I multiply R by C, vice versa, it's definitely not the same because the size was only 1 row by 1 column, so just -21. So when you multiply matrices, they do not commute. Remember, when you multiply numbers, like 2 times 3 is 6, and same as 3 times 2. But matrices, no, they're not really commuting when you multiply, because there could be different size of matrix. And in order to be able to multiply these matrices, you need to have matching entries in the second is a row, no, column of the first with a row of the second. So they must be the same numbers. And that's pretty unusual. And today I'd like to do some more of these multiplications, I guess, just to amuse you. I know it is different, so definitely I'm not going to be asking you to multiply these for a quiz, but I will ask you to maybe look at it as well as at the previous section a little bit over the weekend. And on Monday, maybe we'll see if there'll be a quiz or not. We'll decide. So section 11.4, we have the various little exercises here. And the first group of problems is asking to deal with 3 matrices, and it wants me to add, subtract, and multiply them, maybe by some numbers or by various constants. But what I want to do, I'm sure that add, subtract, you could do without me, but like problem number 15 would tell you to find AC. Well, it's actually a product of matrix A by matrix C. And the way it works, when you write this, I should probably get more room. So I'm going to share with you the board and copy those 2 matrices. So matrix A, if I multiply it by matrix C, it's going to be 0, 3, -5. Our goal is to start to get used to this interesting procedure. And the other is 1, 2, 6. So that's my matrix A. Now matrix C is here. And it's actually 3 by 2. So it looks like matches. It has 4, 1, 6, 2, and -2 and 3. Okay, so copy this I hope correctly. So the sizes of this matrices are 3 by 2. Oh, sorry, 2 by 3. You need to wake up. 2 by 3. 2 rows. Number of rows and number of columns. So we have rows. There are 2 of them. But the columns, there are 1, 2, and 3. So that's why it's 2 rows. So number of rows is always in the first place. Number of columns always in the second place. And for the second matrix, we're going to have 3 rows and 2 columns. So there'll be 2 columns and number of columns again always in the second place, and 3 rows on the first. And since these 2 are the same, then I can do multiplication, and as a result, I'll produce matrix with 2 rows and 2 columns, favored 2 by 2 size. So I can even prepare this matrix. It will have two rows and two columns. That's how the process works. So what I do is I multiply a row by the column. So if it's a first row, first the column, the entry will be here in the row number 1 and the column number 1. And then I go and multiply corresponding numbers. So notice the whole idea is to make sure that we have enough numbers for each. So we multiply in 0 and 4. And then we add it. So we're always going to add it. With next product is 3 and 6. And add it also with the last product, which is -5 and -2. Maybe. See, row and the column. So add it with -5 and -2. And then I move to either here or there. It doesn't really matter in each order. They're not related. So I can continue with this first row. So I go again with the same numbers, 0, 3, and -5. And finally, multiply them by corresponding entries of that second column, which is 1, 2, 3. 2, 3. So without getting a piece of paper and pen, I think it'll be very challenging to recall how this process works, especially if you do this sometime Sunday or whatever. You never have time for this because this is really different. So this is something that one needs to really look at. But it is not hard. So it's something that people get used to. So now I'm going to the second row. So let's say row number 2, these entries. So in the second row, again, there'll be a bunch of entries added together. So the corresponding ones that come from the, now it's going to be only second row. And I start with the first column. So I multiply these corresponding entries somehow like that. So I go 1, 2, and 6, and multiply them by 4, 6, 2. It's nice when they're positive, right? So 4, 6. And finally, I move to the row 2 and column number 2, which is lower right corner. And again, it's same 1, 2, and 6. I always add them. Yeah, that's a procedure. That's actually a definition how this process goes. And I multiply this by 1, 2, 3. So it's not really hard when you get used to it, but the point is try to do the same exact exercise again and everything be fine. You'll start to feel better about this. So what's going on here? 0 times 4 disappear. It's 18 and 10. 18 plus 10 is 28. Over this, you just put it here. Similarly, 0's favorite goes away. So it'll be 6 minus 15. So it's a good idea to have plenty of room for that, right? So 6 subtract from 15 is going to be 8, but you say, Alex, it's not 8, it's 9. Be careful. 9, but it's with negative because 15 is bigger. 15 is with minus. Okay, minus 9. Next, entries. So this is 4, 12, and 12. 24, and 4 is 28. Okay, 28. And finally, The last will be 1 and 4, 5, and 18, which is 23. Okay. That's our matrix. A times C is what we produced. So it's not AC, but it's different. It's a multiplication of two matrices. So again, try to look at it, because without trying to solve this, actually to multiply this, it'd be, I think, kind of hard to get used to it, and most likely one will forget it in a couple of days for sure. So let me go back to the book and see what else is in this little section. I'll do one more, and that should be good enough, because it's really, I think, something very different. I say, okay, so they multiply A by C and B by C. Can they multiply A by B? And the answer is no, because A is a size 2 by 2 by 3, right? Matrix, 2 rows. And matrix B is the same size. It's also 2 by 3. You see, so what? Well, the problem is here. They're not the same. You say, I'll multiply them anyways, Alex. I feel like multiplying. Well, it's not the right feeling for this exercise. Because if you try, what size of the matrix would you get, and how would you be able to multiply it? Because the rule says a row by the column. A row of the first, column of the second, always the same. So if you try to multiply these entries, you multiply 0 by 4, you multiply 3 by -2, but what you will do is -5. I say, I'll just multiply it by 0. Well, but you don't have a 0 here. There's nothing in there. If there be a 0, the size would change to 3 by 3. So 3, yes, it'll work, but it's 2. So it's not possible, and that's why they didn't ask you to do that. But what you can do with A and B, you can actually add or subtract them. Like, for example, let me do the last one, and that'd be good enough for today. You know, it's kind of tedious. Number 10. So if you take A, and if you want to add it with matrix B, so the sizes of matrices are the same. So there are 2 rows and 3 columns. So you can add or subtract them, 2 by 3 matrices. So what you're going to do is take the corresponding entries, like 0 and 4, and if they say, actually they say subtract, they don't say add. They have to be careful. They have to subtract those entries. So minus them. Okay, so subtract from 0, number 4, and you get -4. So addition, subtraction is more straightforward. Multiplication is really unusual. Alex, we say, is there a division? Turns out, yes, but that's multiplication by the inverse matrix. That's something we may look at next time. So corresponding entries, again, 3 with a 1. If I put them together, I get 4. Again, these numbers are random. They have nothing to do with each other, and you just don't need to worry about them. Just add them, or actually what we do is we subtract them. So when I subtract, I should be careful. 3 minus 1 is not 4. It is 2, right? It's important. Make sure you do the right thing. 2 here. Now, -5 and 0 subtracted, it's still -5. The next entries. 1 and -2, notice I subtract negative, it'd be +2 and 1, which is 3. And then 2 and -3, when I subtract, I get -1. And then 6, subtract negative, that'd be plus, right? 2 and 6 is 8. And the good thing about this textbook, it has answers, but it has answers only to the odd numbered exercises, I believe. So at the back of the textbook, you can always check and see that's 11.4 section. So you go to the end of section. If you decided not to do the problem that I do in class, but if you decided to just try something else, you can always try. I would say odd numbered exercises because they have answers at the back. I probably should have found it in the contents because it'd be taking me a while. 11.4 section, I need to find the answers for. Since lots of stuff I need to skip. So it is a little bit tedious here, but what you can do if you like to get there quicker, notice there are page counters on the right side, so you can get to the page, just type what page you need. At this moment, we don't know, so I'm going to show you what page you need. Look at this. There are answers here, and there are answers. Now we need to get to section 11.4. So where are we right now? That's some kind of appendix. That's not that those pages we need yet. E2, but we're getting closer. So those review. So that's chapter 14, right? So we need chapter 11, section 4. So you could actually check all the answers for the odd exercises, I believe. And that's a nice thing. So chapter 11 is 13. I just want to show you the page that you could quickly access. You can just write it down if you. So here's chapter 11 for us. And looks like the exercises for 11 are somewhere on the page like 1120, right? You see 1119 here on the right margin. So 7, still need a little bit. We are in 11.4. So 11.2. Oh, I already skipped it. That's good. So we're there. So looks like page 11.14, 11.15. Right? So you can quickly just type page here on the right side and you will get there. Okay, so notice that 9, 11, 13, 15. So we got all these little exercises solved, and I think I did one of those. I don't remember which one. I think I multiplied a couple of matrices, right? So I'm not going to go there back again, but it was one of, oh, this 2x2 matrix or something, I think we're producing. So anyways, the point is, if there is an odd exercise, you can always find the answer at the back of the textbook. Just go to page 11, something like 1120. So in its neighborhood will be what you need if you decide to try a problem on your own. And I recommend you to just do problems that we are doing together in class. So that'd be the plan. So the next week, we'll keep working on chapter 11. And then the midterm exam, I looked at the syllabus because somebody asked me when midterm is going to be last time. So for the midterm exam, it's going to be on Friday, June 14th, Friday. So Friday, not next week, but week after next. So we still have plenty of time for this. And little by little, we're getting closer to it. So next week, we're going to do a little bit more of chapter 11. We'll keep working on it. And then week after next, before that Friday, we'll discuss the midterm in very detail and send you practice midterm. I will tell you what exercises to look at. I'll give you 2 problems only, not a lot of problems. I know these exercises are tedious, right, and unusual, so I'm not going to really push too hard on that, but they still should be able to do something. So far, we should be doing same problems that covered in lectures. So today we looked at 11.4, and last time we looked at 11.3. So next time we may look at 11.5 or started. So just keep working little by little in chapter 11, and then we'll tell you what exactly the sections the exercises will be coming from, so you will know what to concentrate on during the midterm. So I'm gonna end this class for today. Don't give you a quiz on this. I think we already had a few quizzes, and I'm very happy with how you did on those quizzes. We might have a quiz next week. So I'm gonna stop this recording.
So